I'm literally trying to squeeze in time to make progress in this Clojure thing. I'm not gonna lie, I'm not motivated, but I have someone else using their time to help me, and that's pretty much the only reason why I'm moving forward with this. So last week I was going over hash sets and and lists, and hopefully I don't know what the next part is. So one of the things I need to do is I need to go ahead and launch IntelliJ, which is my IDE. Clean the bathroom. What's that? You can retrieve the rest of your task with that rest function. What I need to do. All right, so it looks like this exercise is creating a function using a list. Yeah, this right here. And yeah, I'm just going to start right here. I don't know what this is. Launch the REPL. I don't know if that means it's successfully launched or not. I would think that there should be some type of like connected status. Let's find out. Shift Alt L. Yeah, it says it's loaded. Okay. Things to remember when you're using the let declaration. That's for scoped symbols, and let will always have a vector in which you do your symbol value pair. And I can't remember if I need to use commas in it or if it's just like that. See the Control Alt P. Yeah, that's fine. What happens when you do a comma? Does it matter? I'm not sure if that matters or not. Hey, observer. So that's kind of what I learned last time. All right. So in this exercise, we will practice using lists by reading and adding elements to a to-do list. Start the REPL and create a to-do list with a list of actions that you needed to do using the list function as follows. So define my to-do, and then we're creating a list. Feed the cat, clean the room, save the world. Okay. Let's do it. Looks like I already have something there already. Start over. All right. So define. And don't I have to do this like within parentheses? Define to do. And then what am I supposed to do within parentheses again? Which is a sincere question. How do they have it? Define to do. Yeah. And then they have list. Feed the cat. And then they clean the bathroom, save the world. Okay. Clean the bathroom. And then they have save the world. Okay, is this right here? Take two. Uh-oh. Take two. Uh-oh. Take two. Right there. I did that part. Then they say you can add items to your list by using the cons function, which operates on sequences. So cons, as in conjoin, I think. Well, but conjoin doesn't have an S in it. Concatenate? I don't know what cons means. So you can add items to your list by using the cons function, which operates on sequences. So cons go to work to my to do. Cons go to work, which applies to do. That should be fine. And this IntelliSense should work. Hold up. Yeah, so X and then sequence. All right, so do that. Feed the go to work. Feed the cat. Okay. And remember, a list is like a linked list, so you just add an element um, to the front or to the end. I guess that's the definition of a doubly linked list. So then, similarly, you can use conjoin function, which is used because a list is a collection. So similarly, so you can use conjoin or you can use cons. The difference is the arguments, which I really wish they had consistency. I wish they had consistency with the parameter positions or the argument positions. So then you can say go to work, feed the cat, clean the bathroom, save the world. Notice how the order of the parameters is different. Cons is available on list because it's a sequence, and conjoin is available to use on list because a list is a collection. Conjoin is therefore slightly more generic and also has the advantage of accepting multiple elements as arguments. Okay. Add multiple elements at once to your list by using the conjoin function. So they have conjoin my to do, go to work, wash my socks. Well, don't I already have go to work in here already? No, I just have, yeah, go to work is already in here. But they're saying conjoin, they're saying this, they're saying conjoin, I think, and then my to do, I think I just call mine to do. And then they have wash my socks and go to work, wash my socks. And they have go to work, which means that I should have a duplicate now for go to work. Go to work, wash my socks, feed the cat, clean the room, save the world. Huh, interesting. I don't have a duplicate of go to work when using conjoin. I wonder if it's going to say that. You could imagine then having to call first on the rest of the list if you had to develop a fully blown to-do list application because the list is immutable. If you keep calling first on the same my to-do list, you will end up with the same element, feed the cat, over and over again, and also with the same happy but very fat cat. Finally, you can retrieve a specific element from the list using the nth function. Nth to do two. All right, come here. Nth to do two. Control Alt or Shift Alt P. Save the world. All right. If I wanted to change that to 3, there is no 3. 1. in the bathroom. Okay. Finally, you can did that. However, remember that retrieving an element at a specific position in the list is slower than with vectors because the list has to be walked until the nth element. In that case, uh, you might be better off using a vector. One final note about nth is that it throws an exception when the element is at position n is not found. That's all you need to know about the list for now, and we can move on to the next section about collection and sequence abstractions. Collection and sequence abstractions. Clojure's data structures are implemented in terms of powerful abstractions. You might have noticed that the operations we used on collections are often similar, but behave differently based on the type of the collection. For instance, get retrieves items from a map with a key, but from a vector with an index. Conjoin, hold up, take two. For instance, get retrieves items from a map with a key, but from a vector with an index. Conjoin adds elements to a vector at the back, but to a list at the front. A sequence is a collection of elements in a particular order, where each item follows another. Maps, sets, vectors, and lists are all collections, but only vectors and lists are sequences, although we can easily obtain a sequence from a map or a set. Let's go through a few examples of useful functions to use with the collections. Consider the following map. So now we say define language. All right, I think I can do this one. A observer. So they have define language, and I think they use the syntax, and then I think they do uh, how do they do this? They say name and then creator. Hold up, name, creator, and then platforms. Okay, so they say name, uh, rich. I don't know how to spell Hickey. Is that how you spell Hickey? Name, Rich Hickey, Ckey. Yeah. And then they say create. No, it's supposed to be name and then creator. So this is supposed to be name, and we'll call this Clojure. And then they say uh, creator, Rich Hickey. And then they say platforms. This is where I'm going to get myself in trouble. Um, theoretically, I should be able to. I think I should be able to do like this, and then say Java. How do I do this? Say Java, and then JavaScript. I don't know if JavaScript has a capital S in the middle of it or not. What else do they have? They have, yeah, Java, JavaScript. How did they do the print? No, they have a vector. Okay. They're using a vector. Java, JavaScript. And then they say .NET. Okay. And so you do let's clear this out. You do a Shift Alt P. Okay, so I did that. And supposedly it does that namespace and then language. Okay, so language is now defined. All right, now what? Use count to get the number of elements in a collection. Each element of this map is a key value pair, therefore it contains 3 elements. So you say count language. All right, say count. Oh, say count language. Just P. It says 3. Okay. Slightly more apparent, the following set contains no elements. This is a hash set. I think so. They're saying do this. They're saying say count, and then saying this p, and that's 0. Okay. And then we can test whether a collection is empty with the empty function. Okay. Empty. In Clojure, every predicate has a suffix of a question mark. Like that, right? Uh-oh, it doesn't. Yeah. All right, cool. Empty, false. All right, cool. How do you say not empty? How do you do that? How do you negate something? They negate it using an empty list. No. That's completely different. How do you negate enclosure? Hold up. Uh, Closure, negation. Yeah, how do you do that? So this is going to be one of my questions. If no, return negation of that. What's this? You do a dash and apostrophe? Is that what it is? Let's see. Uh, let's see if this works. Dash, apostrophe, and let's clean out our REPL, and then yeah, that didn't work. Yeah, so I gotta ask Sergey how you negate. No, it shouldn't be rocket science to figure out how to do this. Hold on. Closure, not. They have this not equal. Hold on, let's try this. Let's see if this works. Not jackpot mother. There we go. Um, Hold on, that's supposed to empty false, not equal. I don't know what I'm doing. I'll ask Sergey how to do all this. All right, so a map is not sequential because there is no logical order between its elements. However, we can convert a map to a sequence using the sequence function. Sequence language. Sequence language. Okay. It yielded a list of vectors or tuples, which means that there is now a logical order, and we can use sequence functions on this data. Nth sequence language 1. Nth. How do they do this again? Sequence language 1. That didn't work. Okay, we got that right there. A lot of functions just work on collections directly because they can be turned into a sequence. So you could omit the sequence step and, for example, call first, rest, or last directly on a map or a set. First, when you have A, B, C, it returns C. All right, that's counterintuitive. Rest, A, B, C, it's going to be B, A. Okay. I guess a hash set is kind of like, it's kind of treated as a queue, kind of. Last language is going to be Java. Okay, so it omits the name or creator, whatever it's called. Last just gives you the platforms. Okay, the value of using sequence functions such as first or rest on maps and sets seem questionable, but treating those collections as a sequence means that they can be iterated. Many more functions are available for processing each of a sequence, each item of a sequence, such as map, reduce, filter, and so on. We have dedicated entire chapters to learning about those in the second part of the book so that we can stay focused on other core functions for now. Into is another useful operator that puts elements of one collection into another. The first argument for into is the target collection. So they have into, and then they have a list of 1, 2, 3, 4. And then they provide a hash set of 5. Oh, shoot. Go back. And then they provide a hash set of 5, 6, 7, 8. And so 1, 2, 3, 4, 5, 6, 7, 8. We can do that. Into, then it was a list, right? That was a vector. 1, 2, 3, 4. Spaces in between. Why can't I just have another vector? 5, 6, 7, 8. I should be able to do this, right? Yeah. So they're just saying you can mix. So they're saying that you can take a hash set and do the same thing. All right. In the preceding example, each element of the 5, 6, 7, 8 set was added into the 1, 2, 3, 4 vector. The resulting vector is not in ascending order because hash sets are not sorted. Uh, Something's not right. Okay, so this study session is adjourned. I got to take care of something. See you.